All right, so all the examples that we've looked at so far involved just adding single digit numbers or maybe 10 plus a single digit number. So let's look at some models where we've got some bigger numbers. Okay, so the first model I want to look at is the concrete model. So we're going to pull out our base 10 blocks again to help us do our addition. So here I've got 14 plus 23. I'm going to pull out one long and four ones for my 14 and two longs and three ones for my 23. And so when I add them, I combine those together. And so kids can visualize here what's happening. I'm left with 37. Okay, so that's called the concrete model. The expanded algorithm, we're going to add our ones and then add our tens and maybe our hundreds if we also have hundreds, and then add those together to get our final answer. So if I wanted to add 14 plus 23 again, I'm going to add 4 plus 3 to get 7, and 20 plus 20 plus 10 to get 30, right? So they need to have already built up this recognition that 23 is really 20 plus 3, and 14 is really 10 plus 4, okay? And then the standard algorithm, we just don't expand that, right? So instead of writing the 30, we add in the ones place and then we add in the tens place. What if you need to regroup? So here's where the expanded algorithm is possibly helpful. So if I add 7 plus 8, that's going to give me 15, which is really 1 10 and 5 ones. But if I'm doing the expanded algorithm, instead of carrying, which is what you're used to doing in the standard algorithm, I'm just going to write that 15 down. Okay, so 7 plus 8 is 15. And now I'm going to add 20 plus 30 to get 50. And now I'm going to add those two numbers. And so I add down 5 and 6 to get 65. That's the expanded algorithm with some regrouping there. Okay, so that's the example that we just saw. And once kids have that expanded algorithm mastered, we can start teaching them the standard algorithm where we carry the 1. Okay, so here I'm going to add 7 plus 8 is 15. I put the 5 ones down and I carry the 110, right? And now I'm going to add my tens. I have 1 plus 3 plus 2 is 6. And so that's going to give me 65. Okay. But we really don't want to start with the standard algorithm, right? Our goal is to help kids understand what's going on. And so that's why we're talking about all of these different algorithms in this class. All right, what if we've got 3-digit numbers and we've got multiple regroupings going? So I want to look at 186 plus 127, and we're going to use the blocks to help us do that. So the first thing I want to do is represent 186 and 127 using the blocks. So 186 is telling me 1 flat, 8 longs, and 6 ones. So that's what I've got up here on top. And then 127 is 1 flat, 2 longs, and 7 ones, and that's what I've got on the bottom. Now I'm going to combine those together, right? Now the regrouping happens, since we're in base 10, every time we get 10 of something, we can glue them together and build them up a level, right? So here I have 10 ones that I've circled in red, and I'm going to combine those together to make a single long. Right? So that's adding the 6 ones and the 7 ones. I get 13 ones, which is the same as 110 and 3 ones. Okay, so in terms of the algorithm, what I do is I write my 3 ones down below and I carry my 110. In terms of the picture, we built the 10 over here. And now we're just going to repeat, right? So now I have 8 tens and 2 tens and 1 10, right? So I want to, anytime I have 10 of those, I can regroup. So I've pulled off 10 of those and created a flat up here at the top of your screen. And so when I add my 110 plus 8 tens plus 2 tens, I get 11 tens, which is the same as 100 and 110. Okay, so I'm going to put my 110 down below and I'm going to carry my 100. And now I'm going to add my hundreds. I have 3 hundreds. So I'm left with 1,313 as my final answer. Those base 10 blocks are really useful to help your kids really understand what's happening when we're carrying or regrouping. All right, here's another algorithm. This is called the left to right algorithm. Sometimes it's called the partial sums algorithm. So the idea here is, so in the standard algorithm, which perhaps a lot of you learned when you learned how to add, you started in the ones place, right, and added. And so the idea here is we're going to start on the left and add. So I'm going to start in the hundreds place and add 500 plus 700. That gives me 1,200. Then I'm going to add my tens. Here I've got 60 plus 50. That gives me 110. And then I'm going to add my ones. 8 plus 7 is 15. And then I'll add those three numbers together to get my final answer, 1,325. Now you can do this in sort of a shortened method. It's a little bit harder to follow, so let me rewrite this so you can see what's happening. So once kids have mastered this left to right, this is what you can do. So we're going to start by adding 5 plus 7, that's 12. Now when I add 6 plus 5, that's 11. So I'm going to scratch this 2 and add 1 to it to get a 3. And then my 1 from my 11, my 1, 1. Okay, now when I add 8 plus 7, I get 15. Again, I need to add the 1 to this one to get 2, and then I have 5 ones. So my final answer here is 1,325. Okay, so that's what's happening there. Really what I would like to see in your work is this left-hand side that really illustrates how you're using the left to right algorithm. Okay, so let's try an example. I want to add 962 plus 681. Okay, so using the standard algorithm, I'm going to start in the ones place. I get 2 plus 1, that's 3. 6 plus 8 is 14, so I'm going to put my 4 ones down here and carry the 1. And now I have 1 plus 9 plus 6. That's going to give me 16. So my answer is 1643. If I use the left to right algorithm, I'm going to start on the left. So I'm going to start by adding my hundreds. 900 plus 600. That's going to give me 1,500. Then I'm going to add my tens. So 60 plus 80. Whoops. Is 140, and then 2 plus 1 is 3, so I have 1,643. All right, you want your students to be able to do any of these algorithms, and you want yourself to be able to use them too, right? We want students to have a large toolkit of methods to approach problems.